Welcome to Process Control Laboratory, which is a virtual laboratory. I am Professor Uttam. Today I will discuss how level control is carried out. But before that, we can see how level can be controlled manually with this two inlet, one inlet valve and another is a drain out drain valve. And now we'll first, you can see this water is pumped from the reservoir to a pump. When you start it, it will go up to maximum discharge of 70 kg per centimeter square pressure, and you can open this inlet valve, then this liquid will be entering into the tank, and level will rise, as you can see here, red level, and you can also drain this tank to adjust the level. So you can control the level either manually by opening and closing these two valves simultaneously, or with the help of two operators. If the valves are at a distance, at least two operators will be required, and it is quite almost impossible because there should be a communication and proper measurement of this level has to be done, because it may not be a glass tank, which will be a steel tank. You cannot see the level. Either you have to put a deep tape or rod for measuring the level of the system. So it is quite difficult to adjust the level at a particular position of the tank, maybe 50%, maybe 40%. Then it will be very difficult. So in that case, we will go for automatic control. I am Professor Uttam. I have developed this with the help of BV6, which has determined this all graphic figures is not the laboratory figure, but you can carry out experiment with this software. Now we'll go to automatic control system. As we have seen, it is difficult to control mechanism manually with the help of two valves. Now we'll go to this automatic system. There is a difference. Here this pump draws water same, and valve, inlet valve is there, which you can open it fully once, and this also must be, drain valve must be kept full open, and then we'll carry out with the help of this controller to control the level with the help of this control valve, where this control valve is normally open, so power to close this valve, and as the level increases, then you have to decrease the flow rate by applying power, and similarly when level is lower, then you have to apply power to close this valve, and this way you can tune this properly, and it will be in reverse mode, that is increase, decrease, that is increase level, decrease the power, and that means more liquid will be out, and in case of lower than the set level, then you will try to close this valve by applying power. So it is a reverse acting mode. So let us start with this pump. We start the pump. See, it is 70 kg the maximum, and then you allow this opening this valve to enter the tank. A liquid enters, a level increases. You can open this valve fully, and now you will make it auto. As it is 0, we can make it say 50%. Set point is 50%. And then press auto. It's automatic. It will, this controller will make this near about 50% here. You can see make it 60%. Maybe 70%. So you can also notice that the pressure drop drops here, discharge pressure comes down, and for uh, for very high flow rate, the pump may trip. For high amperage, it draws. Now we can see that there is an offset, so the controller has to be tuned properly. So make it as, say, this is a reverse acting mode. Increase, decrease means increase the level over the set point, decrease the power so that it will open and more liquid will pass out. And reverse, it is when the liquid level is less than the set point, it decreases, so it increases the power to close the valve. So it is a reverse acting mode properly selected. Now let us take a proportional band is 1 for this particular controller, and reset value is 0 means it is PI control. So make it as P control, and now it is PI control, that is proportional integral control. Then integration time is been given, rate time is 0, and then you will see that it is exactly 70%. And now you can make it as 50%. Maximum level is here, so 50% is here near about. That is, you consider this side, 50% of this side, and you can make it 60%. So it is very quickly achieving this desired level with the help of this controller. Now we can see the recorder. These are all the values, and now it is the 70%, that means the previous record. So press it again to get the next 100 seconds record. So here it is 70%, drops to 50%, then goes to 60%. So you can see what is 60% is 61%. So make it as 60% and then record it. So it is 60% reaching, and now we can make it as 50%. For the next 100 seconds, it will start recording from 50%. And the previous recording 60, now it is 50%. And if you press it again, so it is 50%, exactly 50%. And if you go on pressing it, you will find its 50% is constant, as the level has been maintained. Now you can make it as 80%. 80%. So this is very quickly achieved, which is very difficult if manually tried in the previous case. So here it is 80%. You press the display, you say next 100 seconds record. So you can see here it is 50 and rises quickly to 80%. And see, it is so fast that the PV value, which is slightly fluctuating, is not available here. It is totally smooth. So that is the advantage of this PI control system. You can make it down to 30%. There is slight fluctuation so that you can see the PV value record also. Say it is 50% and press the record and wait for some time. So this red line is showing for 80%, and this is the previous display, and test will come down to 50%. Let us be back and see. This is brought down from 80% to 50%. So there is slight red line was visible, otherwise it is matching with the set point line, blue line. See, it is 50%, and the recorder is also showing you 50%. So this is displayed continuously, is a steady state level has been achieved. You have to wait for some time to get for next 100 seconds. So we understand here that manually operating these two valves and maintaining the level at a constant percentage is quite difficult, as we have seen earlier. But in this control system with the control valve and the controller here, where the level transducer produces electrical signal and enters the controller, which calculates with the help of a control equation, that is here it is a PID equation, proportional integral derivative equation, and with the properly tuned parameters, it is with the help of this control valve, it is controlling very smoothly. I hope you understood the advantage of a automatic control system. There is no need of physical stress for opening and closing these valves, especially when they are large valves and they are quite at a distance. Then it is difficult to operate with the help of two operators also. And time to time you have to see the level with the help of any gauge glass or something else. So all these three operations cannot be done by two operators. There will be three more operators. Three operators will be required instead of two. So here it is automatic control. So only automatic controller with the help of his transducer and control valve is nice smoothly controlling. So anybody sitting in the laboratory, he or she can operate this level at a certain value as desired from the set point. As you go for 60%, it will be immediately 60%. So you just type 60 and you will see that it's 60% reaches. Thank you very much for watching this video.